Okay, this is a 2014 Geometry External, question 1. A wall has been tiled with square tiles. Each tile measures 12 by 12. So we understand that the sides are 12 by 12. They're squares, so it must have a right angle. The length of AC, well, clearly this is a Pythagoras' theorem question. We could call that x. So I know that x squared equals 12 squared plus 12 squared. So x is going to be the square root of 12 squared is 144. Remembering, of course, to have brackets if you're doing it on the calculator in one step. And the answer is 16.970562. And if we do some rounding on that, we'd get 17 to 2 significant figures. We're in centimetres. To 2 significant figures. Keep as many digits as you can because it looks like we could be using the number later on in another part of the question. Describe the triangle ABC in geometric terms. It's clearly right angled and isosceles because two sides are the same length. The third side is not the same length. Right. So now we're making patterns with our tiles. How high is the border? Now these are our tiles here cut in half, so they must be 12 by 12. We want to find that height down the middle there. Because they're isosceles, we can drop a perpendicular and make ourselves a right angle triangle, and that angle at the top there will be half of the 90 degrees, which will be 45, and the reason we know that is because the triangle originally was isosceles. So it's symmetrical. So pulling out that triangle I've got, there's a 45 degree angle there and there's 12 centimetres there. As long as you have one angle on one side, you can find the other angle in the other two sides using trig or Pythagoras. We want to find the height, which is the adjacent side. Here's the hypotenuse, so we're doing a ka problem. For those of us that use the triangles, cos of 45, ka, equals a over h. So one nice line of working, h equals 12 times cos of 45. Working that out, making sure you're in degrees, we'll get 8.5 centimetres to one decimal place. There are other ways you can work that out, just check you've got the right answer. Right, same pattern. How high would this new border be? Distance h in the top. So once again we're back to our right angle. Obviously this side is 12, and if I'm dropping the perpendicular down here, then it will go halfway, which will make this 6. I can see that that whole side there is 12 centimetres. XY is 12 centimetres, which makes half of it 6, and I've got the 45 degree angle again. So pulling out that triangle, this time I've got 6 centimetres here, 45 degrees at the top, and once again we want to find h, the height. So this time I've got the opposite side and the adjacent, so tan for those of us that use triangles, opposite, adjacent, one nice line of working. I can see that h equals 6 divided by tan 45. Working that out on the calculator, we get 6 centimetres, which would make that isosceles. Right, and carrying on, part C, we've got a bit of a puzzle, some pieces moved around. Area of the first one we're told is 64 centimetres squared. You could pause and read the question properly or try it by yourself first. Pieces are rearranged. The new shape seems to have an area of 65 centimetres squared, and yet it's the same pieces with the same areas of each piece. one assumes. So that's a bit puzzling why the area of this square is 64 centimetres squared and the same pieces rearranged have a bigger area. So we'll see what happens with that. Like I said, you can try this problem by yourself. New shape. Calculate the size of angle X in diagram 1. So what have we got? We've got a side of 8 and a side of 3, and that's a right angle because it's a square. So good technique, pull out the triangle that you want. 3, 8, and I want that angle, we'll call it theta. So I've got the opposite and adjacent. Sounds like a problem for tan. Toa, opposite over adjacent, so theta is going to be tan to the minus 1, 3 over 8. And of course there are other ways to do it. Once again, it's quite a long decimal, so we might write down all of it, or quite a lot of it, in case we need it. And then we could round it to 20.6 degrees to 1 dp, just to show we can do some sensible rounding. Right, now we're asked to calculate the size of angle Y in diagram 1 up here. Well, if we find a right angle triangle, obviously that side is 5, and by looking at this, 3 centimetres, 3 centimetres, so that must be 2 centimetres down there. So once again, pulling out the triangle I want to use, I've got a 2 and a 5, and we want to find that angle there. I'm using theta again. Perhaps we could use a different letter like alpha. Once again, I've got opposite, adjacent, putting it in my triangle. Tan of alpha is the opposite over the adjacent, so one nice line of working. Alpha is going to be tan inverse, 5 over 2. Making sure, of course, you're in degrees on the calculator, and that gives us 68.2 degrees. It's rounded to 1 decimal place. Explain why the area seems to have changed. So, having a look up here, it does help, of course, if you've seen this puzzle before. That angle there, obviously it's the same piece arranged the same way. We've worked that out to be 68.2. And if you notice, this orange triangle has been flicked around, and this angle in here we worked out is X, which is 20.6 if we round it. Whichever way you look at it, what happens is when you add these two angles together, you don't get 90 degrees. So this is actually not a right angle in the corner. And if that's not a right angle, then this shape is not a rectangle, and so its area cannot be found simply by the 5 times 13. It's actually a parallelogram. If I just accentuate that, it would be a parallelogram like that, and you don't work out the area of a parallelogram by using the base times the slant height, which is essentially what they've done here. So explaining that, we need to, we'll look at this corner here. We'll call it corner A. We've got Y and we've got X. So corner or vertex A is X plus Y. A equals, remembering there is rounding going on in here, which gives me a value of 88. So even with rounding, it's clearly not quite 90. Hence, A is not a right angle. So the shape is not a rectangle. So its area cannot be worked out by length times height, or 5 times 13 equals 65. That will not be correct. You can write more there if you like.